This is the resultant of the superposition of these waves. We will arrive at the conditions for constructive and destructive interference. Constructive interference to happen, intensity should be maximum. Hello students. In this session of discussion of geometrical optics, I will continue my discussion on interference of light, where today, very importantly, we shall discuss something called as theory of interference, from which I will get conditions for constructive and the so-called destructive interference of light. To recall what is interference, we told it is the phenomenon of superposition of two waves, interference of two light waves. What happens at the point of interference? There is modification in the distribution of light energy. You saw, if the crest is interfering a crest, or a trough is interfering a trough, the resultant intensity increases. If the crest interferes a trough, the intensity decreases. So there is modification of light energy. And what is required for interference to happen? Two coherent sources. So these are sources which emit light waves of same wavelength, amplitude, and constant or zero phase difference. With this recapitulation, now we shall understand something called theory of interference, a very important 5-marker, and moreover, it is from this theory we will arrive at the conditions for constructive and destructive interference. Fine. I'll consider two light waves traveling in the same medium. Two light waves which travel in the same medium with same frequency, same wavelength, and constant phase difference. So, two light waves which travel in the same medium, they have the same frequency, same wavelength, and constant phase difference. We say A and B be their respective amplitudes. A represents the amplitude of the first wave and B represents the amplitude of the second wave. ಎರಡು ಲೈಟ್ ವೇವ್ಗಳಿದೆ. ಅವೆರಡೂ ಒಂದೇ ಮೀಡಿಯಮ್ ಅಲ್ಲಿ ಪ್ರಾಪಗೇಟ್ ಆಗ್ತಿದೆ. They have the same frequency, same wavelength and constant phase difference. Now, what is the displacement of the first wave? Y1 equals A sin omega t. Displacement of the first wave is given by y1 equals A sin omega t, and displacement of the second wave is B sin omega t plus phi, additional term phi, where phi is the constant phase difference between the two waves. Now, y1 displacement of the first wave, which is A sin omega t, y2 displacement of the second wave, B sin omega t plus phi, where phi is the constant phase difference. Now, what should happen according to the principle of superposition? The resultant displacement should be the sum of the individual displacements. Mr. Young has given us this principle of superposition of two waves. Y equals y1 plus y2. Now I make a condition. The condition is A plus B cos phi is represented by R cos theta. B sin phi is represented by R sin theta. A plus B cos phi is R cos theta. B sin phi is R sin theta. Now I substitute for y1 and y2 trigonometrically. I add. I get the condition. Simplification is easy. You can try it out. It is simple trigonometric addition. Y equals R sin omega t plus theta. After simplifying, y equals y1 plus y2. We are arriving at a condition y equals R sin omega t plus theta, represented by equation 3. Now, what is equation 3 representing? My dear students, I assume this is the first wave of displacement y1 and amplitude A. This is the second wave of displacement y2. Amplitude is B. They travel with this condition. What should happen? They should superpose, interfere, and a new wave, we call this resultant wave. This is the resultant of the superposition of these waves, which will have a resultant displacement y and an amplitude r. So here y is the displacement of the resultant wave and r is the amplitude of the resultant wave. Now, I square and add equation 1 and 2. On squaring and adding equations 1 and 2, I get, these are the steps of simplifications. Again, simple trigonometric simplification. I arrive at r equals root of a square plus b square plus 2ab cos phi. See, the equation for the resultant will be the same. Only that it is manipulated in different forms. Here r equals root a square plus b square divided plus 2ab cos phi. A, amplitude of the first wave. B, amplitude of the second wave. Phi, phase difference. So this expression gives the magnitude of the amplitude of the resultant wave and the direction or the phase difference tan phi is b sin phi divided by a plus b cos phi. So from the theory of interference, we have arrived at the expression for the resultant amplitude, which is root a square plus b square plus 2ab cos phi, and the phase difference tan phi equals b sin phi divided by a plus b cos phi. Now this is very important. Based on the expression for resultant, I get condition for something called constructive interference. Now what is this constructive interference? In the previous session I told the interference pattern will consist of alternate bright and dark bands, and these bands are called fringes. Please note, students, interference fringes, alternative bright and dark bands. For example, first we have a bright band, then a dark band, bright band, dark band, and so on. So any interference pattern will consist of alternative bright and dark bands, which we call as interference fringes. They are called interference fringes. A bright band is called constructive band, and a dark band is called destructive band. Bright fringe na constructive band ant karitive, dark fringe na destructive fringe ant karitive. So now, what is the condition for a bright fringe to be formed? What is the condition under which we have constructive interference? Now, we derived the resultant amplitude, and we told the resultant amplitude is of the form root A square plus B square plus 2AB cos phi. Now I want a bright fringe to be formed, constructive interference to happen, which means the amplitude should be maximum. Alva, brightness andreno. When I say brightness, it means intensity should be maximum. Formation of a bright band, constructive interference to happen, intensity should be maximum, which means resultant amplitude should be maximum. This happens only when the value of cos phi is plus 1. If I say minus, this expression becomes minus, resultant decreases. So R is maximum if cos phi is plus 1. For what values of phi cos phi becomes plus 1? 0, 2 pi, 4 pi, 6 pi, etc. Which means phi equals 2n pi. So phi is equal to 2n pi. So this is the condition for constructive interference in terms of phase difference. So 2n pi for, yes, constructive interference to happen, phase difference should be an even multiple of pi. Again I repeat, resultant amplitude has to be maximum. So cos phi in this expression should be plus 1. For what values of phi cos phi becomes plus 1? Your trigonometric analysis says phi 0, 2 pi, 4 pi, etc. So phi is 2n pi. So this is the condition for constructive interference in terms of phase difference. Then in terms of path difference, tumba simple. LL pi ide, alli lambda by 2 hakoli. So path difference 2n lambda by 2. This 2 and 2 gets cancelled. So n lambda remains. So for constructive interference, or bright fringe to be formed, phase difference has to be 2n pi and path difference has to be n lambda. Similarly, destructive interference is the formation of a dark fringe. Again, the same expression, R is root A square plus B square plus 2AB cos phi. Now it is dark fringe, which means the other way, intensity has to be minimum. R has to be minimum, which means cos phi has to be -1. Maximum ge cos phi +1. Minimum ge -1. So for what value of phi? Cos phi will take up -1. Pi, 3 pi, 5 pi, 7 pi, etc., which is 2n plus 1 pi. So this is the condition for phase difference if destructive interference has to happen. Intensity should be minimum, resultant amplitude should be minimum. So cos phi will take up -1 for what angles of phi? Pi, 3 pi, 5 pi, etc., which is 2n plus 1 pi. Now in terms of path difference, now wherever there is pi, lambda by 2. So this is path difference for destructive interference. So my dear students, in today's session, we analyzed theory of interference, and through that I have got conditions for constructive and destructive interference. In my next session, I come up with a very, very important derivation called fringe width of interference fringes. Until then, have a nice time. Thank you.